Okay, so the first thing I'm going to do when I have a function, oh, this is a function, is I want to see if it factors. So I could factor the top into x minus 4 times x plus 2, and the bottom into x plus 4 times x minus 2. And then I want to look for my vertical asymptotes. So vertical asymptotes occur when our denominator is equal to 0. So I set my denominator equals 0 and solve. So I have x equals 2. That's a vertical asymptote, because then this would equal 0, and then I look at this and see that x equals negative 4 is an asymptote. So I label these, and then we are good with the vertical asymptotes. Next is I want to look at my horizontal asymptotes. So remember, horizontal asymptote is what happens, what is the f of x or y approaching when x gets really, really large or really, really negative. So as x approaches infinity, what does f of x approach? So we can remember a rule that if the degree of the numerator is equal to the degree of the denominator, which in this case it is, it's basically just going to be the ratio between those leading coefficients. So because they're both 1, that's just going to equal 1. So we know that our horizontal asymptote is at y equals 1. So this also makes sense. Like if we plugged in 1,000, then we would have 1,000 squared minus 2,000 minus x all over 1,000 squared plus 2,000 minus x. And since 1,000 squared is some huge number, this part isn't really, it's really small in comparison. So it doesn't really matter. And like say we went to 1,000,000 instead of 1,000, this part really wouldn't matter in comparison to when we square our original x. So then we're really just looking at these terms, which are the same. So that's how it equals 1. Okay. Now I'm going to start looking for points, and I'm going to start with my y-intercept. What happens when x is 0? I would have negative 4 times 2 over 4 times negative 2, which is going to equal 1. So my y-intercept is going to equal 1. Now that might be a little confusing because we're on, this is, our y-intercept is on that horizontal asymptote, but we have to remember it's okay if we pass through the horizontal asymptote in the middle here. The horizontal asymptote is only going to really matter out here at the ends. So it's okay if we touch the horizontal asymptote. Now, vertical asymptotes, we can't touch those ever. These are never going to be crossed, but horizontal asymptotes can be crossed when we're in the middle. Okay, so I have my y-intercept, and then I'm going to look for my x-intercept, which is going to happen when the numerator is equal to 0. So when would that be? That's going to be at negative 2. And 4. And then I'm going to just start plugging in a few other points so I can kind of get a picture of what this is going to look like. So I'm going to pick my 1 point at x equals 1. At x equals 1, I'm going to have negative 3 times 3 over 5 times negative 1. So that's going to be 9/5. So I'm somewhere up here. Okay, so now we kind of can get the picture. It's going to look like this, because the vertical asymptotes cannot be touched. Now, I already know I have this point, and I know that as I get further and further out, my points have to approach my horizontal asymptote. And as I get further and further closer to my vertical asymptote, I'm going to have to be going down towards negative infinity. You could plug in points here to just check yourself. And then I need a point over on this section of the graph to understand whether I'm going to be below or above that horizontal asymptote. So I'm going to plug in x equals -5. Okay, so this is positive. It's positive value. It's almost 8, so I'm somewhere up here. And again, I know that this has to keep going upwards as I'm getting closer to the vertical asymptote. And down here, we're going to have to start getting closer to that horizontal asymptote. So here's my final graph.